Welcome to this online revision session for AQA FP3, in which we're going to look at June 2010 question 4 on the solution of first order differential equations. Well, now you can see in this question we're being asked to use the method of an integrating factor in order to solve this differential equation, and then we're given the conditions x equals 1 and y equals 1/5 in order to obtain one particular solution to the problem. Well, if we're going to use an integrating factor, the first thing we need to check is that the equation is in the form that we require. So it's just a single dy by dx is equal to some function of x times y equals some other function of x. So there's nothing we need to do to this. So our integrating factor will be found using the 3 over x. That's the x function that y is multiplied by. So our integrating factor will become e to the integral of 3 over x dx. And we should know the integral of 1 over x is ln, so this becomes e to the 3 ln x, natural log of x. And then using our properties of logs, we know that 3 ln x is the same as the log of x cubed, and the log and the e function are inverses, so our integrating factor is just x cubed. So if we multiply through by x cubed, we will get x cubed dy by dx plus 3x squared y is going to be equal to x cubed x to the 4 plus 3 to the power of 3 over 2. Now this left hand side we should then recognise is the result of a differential of a product, and that product is made up of x cubed, which was the integrating factor, and the function y. And you can see, if we think about differentiating x cubed y, you can see that we got differential of x cubed is 3x squared times the y, and then the differential of y is dy by dx times the x cubed. And so that equals again the x cubed x to the 4 plus 3 power of 3 over 2. So what we now need to do is to integrate both sides. Well, integrating the left hand side, it's fairly obvious. That will undo the differentiation. And on the right hand side we've now got to integrate this function. And we should recognise here that the differential of x to the 4 is 4x cubed, and we've got the x cubed there. So immediately we can put in a quarter here to balance this up. And then we can integrate the power of 3 over 2, which of course we increase by 1, which is 5 over 2. And then we got to divide by the 5 over 2, or multiply by 2 over 5. And then we got our constant plus c on the end here. So if we just tidy that up, we got y equals x cubed, and that equals 1/10 of x to the 4 plus 3 power of 5 over 2 plus our constant. Now we can substitute in our limits, our conditions. When x equals 1, y is equal to 1/5. And so that is going to give us, well, x is x is 1, y is 1/5, so the left hand side will just be 1/5, and on the right hand side we have a 10th, and again x is 1, so 1 to the power of 4 is 1, plus 3 is 4, so we get 4 to the power of 5/2 plus c. So this will tell us the value of c, because 4 to the power of 5/2, well, 4 to the power of a half would be the square root of 4, which is 2, and 2 to the power of 5 is 32. So 32/10 is the same as 16/5, and when I take that across to the other side, or subtract it from both sides, I've got a fifth minus 16/5, which is minus 14/5, which gives us c as being -3. And so we can then state, to finish the question off, what our final solution is going to be, and that is going to be y x cubed equals 1/10 of x to the 4 plus 3 to the power of 5/2, and then our constant is subtracting 3 from that result. Well, there's 9 marks for this part 1 question, so let's see where those marks would have been allocated. Using an appropriate method to find our integrating factor, you get 1 mark, and then stating that it becomes e to the 3 ln x, you get a mark, and then for simplifying it down to x cubed, you get a 3rd mark. And then, having done that, we then would get a method mark and an accuracy mark for obtaining this line here, having multiplied through by the integrating factor and simplifying to this form. And again, integrating this, you get a method mark and an accuracy mark for obtaining the correct result at this point. Then for substituting in your condition values, you'll get 1 mark, and from that obtaining the correct value of c and stating the answer, you get the final mark to give you 9 marks in total. Well, hopefully you found the solution to that problem helpful. For more work on revision for your further maths and maths A level, please go to the Further Maths Support Programme website.